Hello everyone, welcome to MV Tutors. I'm Solo and I'll be looking at vertical projectile motion in one dimension. Alright, in the previous video we covered scenario 1. Today we'll be looking at scenario 2. So let's just get straight to the question. Alright, so this is from a 2019 November paper. And it says stone A is thrown vertically upwards with a speed of 10 meters per second. That already tells me that's the initial velocity. All right, from the edge of the roof of a 40-meter high building, as shown in the diagram below. Ignore the effects of air friction and take the ground as reference. Okay, so I like taking the downwards as positive, okay, and if I take downwards as positive, it means the height of the building they've given us here, okay, so my delta y there, it'll be positive 40. My gravitational acceleration will be positive 9,8 meters per second squared. My initial velocity, because my initial velocity is facing upwards, it'll be negative. All right, so I think we have everything. So the motion of this ball, basically, if I were to draw a displacement time graph, it would look something like this, where my initial velocity here, okay, so it's going to be negative, right? And also taking my velocity this side, it will actually be equal to my initial velocity, but it will be positive. Okay, so this one is negative 10 meters per second. That will be positive 10 meters per second. And I know at that point there, my velocity is 0. All right, so yeah, and then here, that is when I'll have my maximum velocity. So those are things that you can just bear in mind, okay? And then since the motion of the ball is going up, or rather stone, not ball, your delta y there will be negative, okay? And in this case, where the stone is going downwards, my delta y will be positive. Okay, so those are just things that you can always mark or take be aware of as you answer these questions or just read through it. All right, so let us go to the question. All right, so define the term free fall. We defined it in the previous video, but we can do it again if somebody's joining us for the first time. Okay, so if we have free fall, your object, okay, the object is free from any kind of disturbance. Okay, so that's the first point. The object in this case is the stone. Okay, it's free from disturbances as it falls, hence free. Yeah, free from disturbance. All right, secondly, they've stated it here that we should ignore the effects of air friction. So yes, if it's free, it means no effects of air friction, if I could say, yeah, if I could put it that way. Okay, so I would say there's the absence of air friction. And the most important thing is about free fall, the only force acting upon your projectile, there's a stone in this case, is that only gravitational acceleration is acting on it. Okay, so the only force influencing, or rather the only force upon the projectile is gravitational acceleration. Gravitational acceleration. Okay, so that's basically what free fall is. All right, yeah. Now in 3.2, they're saying calculate the maximum height above the ground reached by the stone. All right, so your maximum height in this case, we are looking at this whole height here. Okay, so you have your 40 that you know, but then we need to calculate what that height is. And to do that, we're going to use our equations of motion. Okay, I'm just going to pause, write them down quickly, and then we'll continue with the question. Okay, guys, so they want the maximum height above the ground reached by stone A. Okay, so what do we know? What information do we have? We have our initial velocity here, right? And then we have our final velocity here. We know that it's 0. We know our initial velocity is 10. We're going to take it as negative 10 meters per second. And yeah, let's have a look at our equations of motion and see which one will be applicable. Okay, so the first one here, it has a time factor to it. We don't know anything with regard to time, so we're not going to really look at that. And then the second one has height, which is what we are looking for, right? So we have our final velocity, we have our initial velocity, we know the gravitational acceleration, so we're good to go. We can't even use the third one again because it has time. It has a time factor to it. So we're going to use the second equation, all right, which says the final velocity squared is equal to the initial velocity squared plus 2. Remember, we chose downwards as positive. I'm just going to put a g there instead of a. And then delta y. We know our final velocity is 0. Okay, 0 squared is 0. Our initial velocity is negative 10. Okay. Our gravitational acceleration is 9,8. And our unknown is delta y. So, making delta y the subject of the formula, we have, if I were to take 10 that side, it would be 100. 10 squared, and then we have 2 times 9,8. That's 19,6. And then yeah, we can calculate what that will give us. Okay, so 100 divided by 2 times 9,8. 9,8. So that is 5,10. Okay, I'm just gonna round it off to 2 decimal places. Okay, that is the height. But what we have just calculated, let me just try to redraw the scenario again. You have the stone going in that way. Okay, we know that this height is 40. We just calculated that height as 5,01 meters. So now the total height, the maximum height. Okay, so delta y max, that is going to be 40 plus 5,01, which is 45,01 meters. Okay, let's attempt the 3.3. So it says write down the magnitude and direction of the acceleration of stone A at this maximum height. So at this point here, what is g? Okay, what is the acceleration? Yeah, this is going to be straightforward. The acceleration, it's actually equal to 9,8 meters per second squared. Don't forget your units. You actually do get a mark for that. And the direction is downwards. Gravitational acceleration is always acting towards the earth. It's downwards. Okay. Now, what's happening in 3.4? So they're saying stone B is dropped from rest. So we know our initial velocity is 0. From the edge of the roof, X seconds after stone A was thrown upwards. So stone A passes stone B when the two stones are 29,74 meters above the ground. Okay, so let's just draw the scenario. I like drawing because it makes things simple for me to understand what is actually going on. Okay, so I have my building here, and that is the ground. Okay, what a building. Okay. And then I have stone A, okay, which was dropped. Remember, no, I think that's stone B that was dropped. So that's like a scenario 1 type problem. So you have this, it was dropped, okay, and it reaches the ground. Then you have stone A, okay, which was first thrown upwards and then reached the ground. Okay, so it was first there. All right, now they tell us that 29, when they are 29.74 meters above ground. Okay, 29.74 meters above ground. All right, so I'm just going to say it's somewhere there. Okay, so that is 29.74 meters. Okay, they are at the same level. Okay, so both of them are at the same level, or rather at that level, that elevation, they are there at the same time. Okay, stone A managed to catch up with stone B. All right, and just a reminder that the building's height is 40 meters. All right, what else am I missing? Okay, if you wanted to know what that height will be, you just take 40 minus 29.74. Okay, that's 10.26. Okay, so what are we looking for? Let us just go check again what the question is. All right, so it's saying, so the second stone, stone B, is dropped from rest, okay, X seconds after stone A was thrown upwards. So we want to know what those seconds are. That's what we're looking for. And then stone A passes stone B when the two stones are 29.74 meters above the ground. Okay, so we are looking for X. All right, awesome. I want to know stone B. Okay, so this is stone A and that's stone B. I want to know for stone B, at what time does it reach this elevation there? Okay, so which equation of motion will I have? I have my initial velocity. I have my delta y. I'm looking for delta t. Okay, so the equation I'm going to use, I have delta y. I'm looking for time. I have initial velocity, so it's this one. All right, yeah, delta y. So I'm looking at stone B. So delta y is equal to initial velocity times time plus half a delta t squared. All right, so we have our delta y, and we've taken downwards as positive. Remember, if you choose downwards as positive for all the questions, you're going to have to remain with that decision. All right, so 10.26, that will be positive. My initial velocity is 0 because it's dropped. Okay, it's not thrown. And then gravity acting downwards, it will be positive. So my unknown is t. All right, so t squared is equal to 10.26 divided by a half times 9.8. So t is equal to the root of all of that. Okay, I'm just going to plug it into the calculator. So the root of 10.26 all over 0.5 times 9.8. Okay, and our answer is 1.45 seconds. Okay, rounding off to 2 decimal places. All right, cool. So we know that stone B, at this point, it reached that point at 1.45 seconds. Now we want to know for A. when it gets to that point, how long would it have been? Okay, so what are we going to do? My plan is to first determine the time it takes for A to reach its maximum height. Okay, so I want to know what the time is there. Then I know the time it takes for it to go from the starting position to the maximum is equal to the time it takes for it to go from the maximum to here. Okay, so I can have this whole time, but there's that little time that's missing there. So I could try to get that part, or I could get to the time here first and then just calculate the time there and add the two. I think that's much simpler. Okay, so I have my initial velocity, I have my final velocity. I'm just short of the time. Okay, we did calculate the height above, but just in case that calculation would have been wrong, I don't suggest you use the same answer. If you can't, then use it. But let's see. So I have my initial velocity, I have my final velocity, and I'm looking for time. So I'm going to use the first equation. Okay. So for stone A, I have my final velocity is equal to my initial velocity plus the acceleration delta t. Okay, my final velocity is 0. My initial velocity is -10. And my gravitational acceleration is that. Okay, so t, if I take 10 to the other side, it will be 10. And then I have to divide by 9.8. Okay, so now the time it took to reach the maximum height, that will be 10 over 9.8, and that is 1,02 seconds. Okay, oh, should have just written it there. Alright, so that's 1,02 seconds. And then now, so the time that I've calculated now, it's just from this point to the maximum. Now I need to know from that point to that point there. And what I can do, I know my velocity here is 0. I don't really know what my velocity here is. Okay, it's fine. I have the initial velocity, sorry. I know what my height is. Okay, here. Okay, so I'm gonna have to just use it. I think it was 5,1 or 5,01? Okay, 5,1. So I have my initial velocity, I have my height, I'm just missing the time. So what can I use here? Initial velocity, I have the height, I can use that. Okay, so yeah, that's not bad. Yeah, delta y. So delta y is equal to the initial velocity times time plus, is it half? Yes, plus half the acceleration times squared. So my y there, that was going to be 5,1 plus the 10,26, right? Yes, 10,26. My initial velocity is 0. Okay, and then I have the gravitational acceleration, and I'm looking for time. All right, so t squared is 10 plus 5, that is 15. I have 3,6. All right, 15,36, and dividing it by a half of 9,8. Okay, actually, if I want t, I can root that. All right, so let's just plug this in the calculator and let us see what we get. Okay, 15,36 over a half times 9,8, and that is 1,77. All right, 1,77 seconds. And guys, that is just this one over here. Okay, so if I add the two, okay, so I have 1,02. So the total time, if I were to say, maybe this is 0.1, that is 0.2, and that is 0.3. So if I want the total time from 0.1 to 3, that's when I'm going to add the 2. Okay, so time from 0.1 to 3, that is actually 1,02 plus 1,77. And then your final time it took from 0.1 to 3 is 2,79 seconds. Okay, great. But we still have to solve for x. So what is x, guys? Let's go back to our sketch. So it took, okay, for ball A, it took a total of 2,79 seconds to reach this point 3. And then for ball B, why do I keep saying ball? For stone B, it took, I actually forgot the time, I think 1,45 seconds, okay, to reach point 3. So if I want to know what x is, I would have to take 2,79 and subtract it from 1,45. All right, and get the time. Remember what the question was. Let's just go back and remind ourselves. Ball B is, stone B is dropped from rest from the edge of the roof x seconds after stone A was thrown. So x just represents the seconds. After throwing that, then you threw that. So what is the difference? Okay, that is what we're looking for. So ultimately then x is equal to 2,79 minus 1,45 seconds. And then our final answer, okay, yeah, 1,34 seconds. Okay, awesome. Now we're going to have a look at the last question, 3.5. So here it says the graphs of position versus time for part of the motion of both stones are shown below. So basically just looking at this, what do you think, which do you think is stone A and which do you think is stone B? I think it's quite obvious. Stone A is that one, it takes that motion, and stone B is this one. Here, that is where they met. That was, I think, 29,74 meters above ground. All right, and then they all go together to the ground. So what are the questions saying? Right, they want to know, okay, so which of the labels A to H on the graphs above represents each of the following? So the time at which stone A has a positive velocity, right? Remember we took downwards as positive, okay? So if the motion was going up, it's negative. So this side, you have negative velocity. And on this side, you have positive velocity. So the time at which stone A has positive velocity, I would say is from E to G. Okay, so 3,5,1. Sorry for the noise outside. So I would say positive velocity is in between E and G. Definitely not exactly at E, because at E you have zero velocity. It starts now getting positive or gaining as it goes down. Okay, then 3.5.2, the maximum height reached by stone A. So maximum height, that is A. Okay, I think you can see that. That is the maximum height. So that is A. I'm just write it down. 3, 5, 2. So that is A. Then 3, 5, 3. The time when stone B was dropped. So stone B was dropped at F. Okay. And then 3, 5, 4. The height at which the stones passed each other. They passed each other at C. Okay. All right. Yeah, and that is it. That concludes our session for today. Thank you for joining me. Please, if you need private tutoring, don't forget to visit our website, www.mvtutors.co.za, and then you can make an appointment and we can assist you. All right. Thank you guys. Don't forget to like our video and subscribe to our channel. Bye.